Hi and welcome back. In this video we'll discuss a good topic, which is intersection over union and how to implement it in Python. So intersection over union, I think you know it. It's evaluation matrix which is used to measure the accuracy of object detection. So for simplicity and for seeking or of making this video more simple, we will not using we will not building the algorithm using midpoint and height and width. Instead of, we will build it just using the 2 point, which is the algorithm output. So also we will make a convention which is using the lower left. Okay, when we draw the point, we use lower left for the first point and upper right for the second point. Okay, it's very simple. It doesn't matter if you use any convenient, which is like I think some people use 0 and 0, and then 0 and 1, then 1 and 0. Okay, it doesn't matter if you use any convenient, but I use the convenient which is used in this website. So let's see how we will solve this problem. If we have this bounding box, which is the true bounding box, which is we train our model on it, and this bounding box, the blue one, is the bounding box which our algorithm detect. Okay, so there is an intersection here between those two bounding box. What we want is to see if those two bounding box are somehow overlap each other like this. This mean it's good detection. But if they are away from each other, this is very bad detection. Okay, so what we want to do is getting the area of the green box. What we can think about it is getting them from this first point and this first point. We want to get up as possible and left as possible. Okay, to go up we can get the maximum of x. So here we have 2 and here we have 1, so it will be 2. Okay, so we go with 2, and for y it will be also the max. So we have here 1 and here 2, so we will go with 2 and 2, and this is true, which is the lower left of the green box. We want to get this point. Okay, how to get it, we will also want to think about it. How we can think about this problem? We want to get left as possible and down as possible. So going left is minimum and going down is also minimum. So we will take the minimum of those 2 points. Okay, so 4 and 3, what is the minimum value? It is 3, so we will go here and pointing 3, and 3 and 4, which is the minimum? It is 3, so we will go 3 here and 3 in x and 3 in y. So we have got the 2 point of this intersection box. From those 2 points we can get the width and the height. Okay, the width of and height, width of any 2 points, it will be x2 minus x1, and height will be y2 minus y1 of any box, either it was this red one or it is blue one. Okay, and the intersection, of course, it will be the intersection over union, it will be the the area of the red, the area of the blue, plus the area of the red minus the area of the green. That's why we have to get the area of the green. Okay, let's see the code. It will be very simple as you understand this step. What we have here is a function. You give this function two boxes. Each box contain 2 points. The first point is as we see it, is the lower left point, and this point is the upper right point, and also for this point. So for the xi1 and x and yi1, those points are the point of the box of intersection, the green one we have drawn. Okay, we get the maximum of those two, and for x2 and y2 of the green box, we get the minimum of the 2 points as we see. So the intersection width and intersection height, width will be y2 minus y1, and height will be x2 minus x1. Okay, it doesn't matter. Here I have a change, but it doesn't matter because in the end we will multiply those two scalar variable. It doesn't matter if you will say this will be the width, okay, which is x, and this will be the height, which is y. It doesn't matter. Okay, for this 0, I just to let you know, sometimes you have this box and this is a true bounding box, and the predicted bounding box, it will be overlapping it, so you will have intersection of 0. Okay, so the intersection area, it will be multiplication of those two scalar variables, and we getting the area of the first box, which is x1 minus x2 minus x1, and y2, the width minus the height, multiplied by height, and the same for this box. Okay, then we getting the union, which is the first box area plus the second box area minus the intersection area, and to get the union of intersection, it will be the intersection area divided by the union area. Okay, it just an easy like that. And if you test this data on it, you will get what you want. Okay, thank you and bye.